Okay, so today we are learning about the combination of resistances. Now there are actually two combinations possible. First we call it series combination and the other one will be parallel combination. So these are the two methods of combining the resistances which are more in number. That means at least three should be there. Okay, to have such type of combinations, at least three resistances should be there. So we are having three resistances R1, R2 and R3 and they are combined together in series. First we are taking series combination. Now the question is, what is in the series combination? So there are some points we should keep in mind before studying this series combination of resistances. I hope resistances, you know what is meant by resistance wire. Resistance wire means a type of material of the wire which obstruct the flow of current through it. That means it does not allow the current to flow through it. That will be called as resistance. Okay, if the resisting power is more, that means it don't allow any of the current to flow. That means it will be of higher resistance. And if it allows some quantity of current to flow through it, then it will be called as of low resistance. So here we are having three resistance wires which are connected in series. Now series combination, in series combination we are joining the wire end to end. You have to remember these three words, end to end. Okay, it's a phrase that wires are joined end to end here. That means one end of first wire is joined to the second end of the second end of the first will be joined to the first end of the second wire, and in this way they are joined end to end. Okay, now when these are joined end to end and the battery is connected, a battery or a cell is connected, then the current, we know it flows from plus to minus. It will flow in this manner, in this direction. So current starts from here, positive of the battery, and it will go through this wire, and the same current will be moving through the second and the third wire. That means the current flow will be same in this condition, or in this type of combination the flow of current will be same. So you have to keep in mind that in series combination the resistances, they are joined end to end, and the same current flows through each of the wire. Don't write that the resistances are joined in series. We don't know the meaning of series combination. So if we ask you the meaning of series combination, then don't write they are joined in series. We have to say that they are joined end to end. In this manner they are joined and the same current flows through each of the wire. Now what about the potential difference? Potential difference is actually we are providing with the help of cell or battery, right? So potential difference, suppose we are taking it as V, then this potential difference which provides the current, this is always divided among the three wire when they are connected in series. Okay, so in series combination, potential difference is always divided, right, as it is shown. So what we have seen till now, that in series combination the wires are joined end to end, the current remains same throughout the wires, and the potential difference is divided according to the value of resistance. Now this potential difference, they are not divided equally. It is not same in all the wire. It is same only when the wires are of same value. If the wires having different value of resistance, then potential difference will also be different. Okay, so in this condition we are not taking same. They are of different value. So obviously potential difference V1, V2, V3, they are of different values, but their sum, the sum of all the three will be equal to this total connected voltage, right? So this V will be equal to V1 plus V2 plus V3. So the three things which we have to learn, that joined end to end, current same and potential difference is divided. Now you note down all the three factors in your copies. When we solve this derivation, then this figure is very important for you to draw in the copy in the beginning only. Don't draw in the last. Don't forget to draw it, otherwise marks will not be given if you don't draw the figure. So figure should be drawn as it is. All the things will be marked here. This is the switch. This is the switch or the key we call it. Since the dot is inserted, dot is there, that means it is a closed key and the current is flowing in the circuit. The potential difference, here to here it is V1, here to here it is V2, and from here to here it is V3, and the total potential difference will be equal to V. After this we will come to the derivation, the mathematical part of the question. So first you try to understand this much part, figure if it is clear to you, then we can proceed to the next part or the next steps. we will be using Ohm's law in deriving the formula for series combination. So Ohm's law is required here, that you know very well. What is Ohm's law? That means if we provide higher potential difference, the current drawn will be higher. More potential difference, more current. Less potential difference, less current. So we can say potential difference is directly proportional to the current flowing in the conductor. Potential difference is directly proportional to the current flowing through the conductor. This is called Ohm's law statement. This we need to follow here in this particular derivation. So by Ohm's law we have V equal to IR. Now this is the expression for Ohm's law. This V equal to IR is very important, and this is called the expression, the mathematical expression for Ohm's law. So we start with here V equals to IR. After this we come to the step. Already I told you that potential difference is the combination of the individual ones. That means we will write the second step as V equal to V1 plus V2 plus V3. V equal to V1 plus V2 plus V3, and let it be first condition. After this we will apply Ohm's law for particular resistance. For individual resistances we will apply Ohm's law individually. So for the first resistance, if we take only this first one, here the resistance is R1, current flowing is I, and potential difference is V1. So here it becomes V1 equal to IR1. Similarly for the second one, V2 equals to IR2, and for the third one, V3 equals to IR3. Okay, so we have applied Ohm's law for all of these resistance wires individually. So we are getting these equations now. Equation suppose second, equation third, and fourth. We are getting these equations. Now these equations we are putting in the first one. That means from these four equations, from 1, 2, 3, 4, you can write, we are putting the values here. In place of V1 we are writing IR1. In place of this V2 we will write IR2. In place of V3 we will write IR3. So finally we are getting this expression. Also in place of V we will write IR from here. So this V equal to IR plus IR1, IR2, IR3. Here we are writing that in the form of expression. After this, very simple calculations. Just you need to take out I common from the RHS side. I is common from the RHS side. Cancel it from both ways, both sides, and finally you are getting the expression R equals to R1 plus R2 plus R3, and this is the final expression for series combination of the resistances. This expression defines the series combination. Now what happens in this case? What happens to the total resistance of the circuit? When the wires are connected in series, then the total resistance of the circuit will be equal to the sum of the individual resistances. Right? The total resistance of the circuit will be equal to the sum of the individual resistances, and the overall resistance of the circuit will go on increasing. The overall resistance of the circuit will be increased because of the addition of these three individual resistances. And the same formula can be applied to any number of resistance, not only 3, it can be applied to 2, and it can be applied to more than 3. So this is the final part of the expression. Okay, so after this, now we come to the parallel combination of the resistances. So first let us understand what is meant by parallel combination of resistances. Now according to the statement, 3 or more resistances, we can say 3 or more resistances or 2 or more resistances, they are said to be connected in parallel only if their one ends, their first ends are joined together at one point and the second end is joined together at the other point. So all first ends are joined here and all the second ends are joined at the second point. So this type of combination will be called as parallel combination. Now here we are taking 3 resistance wires R1, R2 and R3 connected in parallel, and the current flowing through the circuit is supposed to be equal to I. The voltage we are providing here, that is V, This is the switch again, also called as key. So this type of circuit arrangement it will be called as parallel combination, right? After this, let us come to the same points again as we have discussed in the earlier derivation. So the first point, all the first ends joined together and the second ends are joined together at second point. This is the same point. Then current is divided. Now in the earlier one, in the series combination, we have current same and potential difference divided, but in this one we have got potential difference same and the current is divided. So they are the two opposite things, right? This is the reverse of the first one. So here potential difference remain same and the overall potential difference will be equal to V only, right? Between these 2 points the potential difference will be same as we are providing through the cell or the battery. So current is I. Now you can see here that current is divided into 3 parts, I1, I2 and I3. Current is divided here, I1, I2 and I3, and again the current joins and becomes equal to the original value, that is equal to I. So current is same, so current is divided and potential difference will be same. Now after this, again we need to apply the Ohm's law here. Again we are applying Ohm's law, V equals to IR. Before this, let us write the expression I equal to I1 plus I2 plus I3. Okay, this is the expression I equals to I1 plus I2 plus I3, that is the total current is equal to the sum of the individual currents. So let it be equation number 1 here, that is the total value of the current. After this we come to the Ohm's law, that is V equal to IR. Okay, V equals to IR, this is the value of, this is the formula of Ohm's law, mathematical expression. So here we come to the expression for Ohm's law. Now for individual wire, we are applying the formula for Ohm's law. So here I1 equal to V by R1. For the overall resistance, I equal to V by R. Here I1 equal to V by R1, I2 equal to V by R2 and I3 equal to V by R3. These are the individual values of the currents. These are the individual values of the currents. Now total currents we are combining here, I equal to I1 plus I2 plus I3. Right? After this, I am writing here we join them together, we will get V upon R equals to V by R equals to V by R1 plus V by R2 plus V by R3. So we are putting the value of currents, okay, in this expression. Here we are applying Ohm's law. Now this V is common throughout, which will be cancelled. After this, V is cancelled and we are left with this expression. Finally, so this is the final expression for parallel combination of the resistance. 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the expression for parallel combination of the resistances. Again, in this derivation also, you need to draw the figure. Without figure, we cannot understand the mathematical part of the question. Okay, so figures are very important in all the derivations. Here we are finished with the series combination and the parallel combination of resistances. So again, these two very important derivations regarding the examination point of view, and very frequently these questions are asked in the exams, and also numericals based on these questions are asked. Okay.